Hi. So, I enjoy simple pleasures in life. As all of us, you know, sex, drugs, family, friends, girlfriend, and the software. And sometimes the software is better than other things, because, you know, satisfaction lasts longer. And this is one of the things that I really enjoy. This is our own distribution, and this is boot screen. There is the group. You can choose the kernel, the version that you will boot. And I'm really proud of it. One day, my boss asked me, Alex, tell me, how can we know that our distro will work on different software with different configuration? How? And I will be honest with you, this question haunts me ever since. Because there's 1,000 of projects in every distro, and how can we test it? And I was searching the answer, and this searches brings me here. So, ladies and gentlemen, I would like to welcome you to Linux Distribution Automated Testing. I'm Aleksander Baranowski. I'm software contractor. My main client is Linux, and we will start. These 3 simple lines. Oh, sorry. These 3 simple lines separate my life from being a Linux user from being a Linux user to being the power user, the someone who uses heavy modified operating system. I'll be honest with you, when you want to start a new Linux distribution, you will probably start with Linux from scratch. This is the book, the project that shows how you can make your own Linux. Like from scratch, really scratch. You don't even need the Linux machine. You can start with some Unix, whatever. And the half of this book looks like this. Configure the project, make the project, install the project. Okay. Oh, it's not working. It should now. Okay, so at the first glance, when you are thinking about making the Linux distribution, or generally speaking, operating system, it's suicidal mission. There is no chance to success. So, we are using the simple algorithmic approach called divide and conquer. Of course, I'm not talking about the divide and conquer and the way that algorithm works, but let's speak more like generally. So, we split the Linux distribution into the smaller packages. And these things that are smaller can be easily tested, replace it, and make. Packages. What are packages? Packages is software with data, with all the scripts that are necessary to install, update, uninstall, and so on. So, because, as we all know from one of the great principles of software testing, the software testing is context dependent, yes? So before we start talking about how we will test the Linux distribution, I want to take you to the journey about how we make the Linux distribution and what are the problems. But before it, we have to make the basic glossary, so each of us will know what we are talking about. So, the Linux. The Linux is monolithic Unix-like computer operating system or kernel. And this is quite important because even as Linus Torvalds said, we shouldn't say Linux, we should say GNU Linux when we are talking about the operating system, and we should speak Linux when we are talking about the kernel. But even Linus Torvalds himself always talk about the Linux as the operating system. So, the next thing is the Linux distribution, also called the distro. And this is GNU Linux operating system, this is the specific implementation of it. The next thing that might be unknown for some of us is the Upstream. And Upstream is the original author or maintainers, may refer to the whole project, organization, or even the single person. Next thing that we have to know is repository, with a set of packages of metadata, and system image, And crowd image were the frozen state of the system. For example, installation image, Amazon machine image, Docker image, Vagrant images, and so on and so on and so on. But before we make the Linux distribution, we have to answer 4 big questions. Right? Very, really big question. The first one is, which software should we pack? And I will give you a short example. There is the SSL, Secure Socket Layer. This must-have in the Moscow methodology. We need it everywhere, in the web, with SSH, and so on and so on. And as someone who wants to make the Linux distribution, you have to answer yourself, which one I should take? Right now, there is Google Boring SSL, there is OpenSSL, and BSD Libre SSL. And which one? It's not the simple question. Why? Because so many software depends on which one you should choose. And what is even more important, and this is the part of something what I call the Linux hell, none of them will have the same API and ABI. API is application programming interface, ABI is application binary interface. Application binary interface is even more fragile than API. And this is quite a huge problem. The next big question is versioning. How we will version our distribution. And there are 3 popular models. First one is long-term time support. And this is quite popular with enterprise Linuxes. You know, each company, especially the big one, need about 2 years to make some change. So before they decide that they will use this software, they need a minimum a year. So this is the first model. The second one is the rolling release. It's loved by software developers and power users because you always have there's only one state of the system, the newest one. The repository represents always the newest one, so it's always the bleeding edge. So whenever you think about, they will make this cool feature in my favorite language, on my favorite framework, library, or whatever, when you have the rolling release, you will get it first. And there is a hybrid, so there's point release, like for example Fedora 29, but with much shorter lifespan. So you get the the newest software, but a little bit more stable. The third question is if you want make this guy happy. And the person who will answer me who this guy is the first person I would like to give a gift. So. Okay, tam chyba pan był. Can you give it? Okay. Okay. Zadasz później. Okay. There was another one. So. Thank you very much. Okay, virtual Starman. And this is quite an important question because lots of people, especially in Linux systems, believe that you should use only free and libre software. Only. And to be honest, this is quite a hard... I don't know, sorry. Okay, so, and you should only run free software. So, for example, some of the video codecs won't be available in your distribution. Flash player and many, many things, forget about it. The decent Java, but it's not open, Java development kit, forget about it. And a lot of distributions are proud that they use only the free software. For example, there is Arch Linux and there is Parabola Linux. And Parabola use only free software, and I know people who love Parabola and will come to it. No, you are using the proprietary software, you are the bad person, believe me. You want to pay for the software, you are a bad person. Okay. And the last one is how the software will be packed. And we have two models, the source and ports and binary. When you think about the source, it means that each time when there is the update, you have to take the sources, compile it, then install. And when you have binary, someone else compiled it and you just download it and run. And which one is better? In theory, people love the source because For example, I have my personal computer, and I don't need generic kernel image, because the generic kernel would support about, I don't know, 1,000 CPUs. I can make my own kernel. Yeah, I will compile it. And it will work only on my CPU. It sounds great, but doesn't work. Why? Because when you have 10 computers, it starts to be really cumbersome. What about when you have thousands? Or if you have the whole cloud to manage? It's shortly become more and more laborious. And what is even more important is that people tend to believe that source images are lighter, faster, and so on. This is not the truth. I will make the short proof. We have a client that needs really little images for the cloud. Little, like 200 megabytes. 100 for the software they install. Some of the things should be loaded especially and so on. There is no manual pages, the libraries are stripped. And when you have a source software, in order to update the system, because there finally will be some critical vulnerability in it, you will need the whole tool chain. And this tool chain is bigger. The size of it is bigger than the whole distribution that we made for this client. Okay. The next thing is how we will make packages. We decided what we want, how this distribution should look like, and we want to make the packages. So this is the ASCII art that I made. This is not an art by it. We have the upstream. The packages take the upstream, make the package, and put it into the distro. Nothing special. And packager needs to monitor the state of the packages. And if this, for example, there can be the newer release of the software, and it needs the repacking. What is also important, the packages are not self-sufficient. There is always the dependency. For example, to run, I don't know, the Python, Jinja 2, for example, from Python, okay? There's some template engine. And I need Python 2 in order to get it running. The next thing that is important when we call about the packages is that sometimes the build environment is much different than the runtime. I will talk about it later when it comes to the testing, and there is also one big problem, tests and day zeros. How we should maintain it. As I said, I will talk about it a little bit later. And there is also apropos the packages. Before we have the manual, now we have apropos with the Linux commands, by the way. And there is the dependency hell. The dependency hell is eternal, like Doom Eternal, the new game by ID Software I really want to play. And you won't see it, because you have a packager who will have to resolve it. But deep down inside the heart of the Linux, there is still dependency hell. And what is also important that is that the package provides a lot of meta-infos. And for us as a testers, or someone who wants to test Linux distribution, there are three meta-information that are really important. The first one is what the package provides. Second one, what is required and what build require. And third one, what build require. Okay. After we make the packages, we can make the repository, so set of packages. Repository have the groups and the environments in it. And now we'll talk about it. So after making packages, we can move to the next step, making repository. Groups and environment are skippable. You don't need them. They're inconvenient, but this is not must-have. Okay, so the repository has a lot of meta information about the packages, like name, version, release, so on, file, release, provided by package, checksums, changelog, so on, so on, so quite a lot of things. And the one that is really important is keys used to sync the packages. The security-related feature that is one of the critical in a Linux system. And the repository also have information about the groups and environments. The packages shouldn't have this information themselves. Okay, so what is the group of packages? Is the group of logically linked packages. For example, one of the most important groups that every Linux distribution should have is core or minimal. The name can differ, but what is really important is that this group is as small as possible to run on every system. And when you are using the installer, you just say install the minimal. And from now on, you can do everything with your system. It will install. The other groups, for example, file transfer protocol server, or whatever you like, to be honest. What is also really important is that there is no standardized way in Linux how we should group the packages, how we should group the software. This is one of favorite arguments against the Linux and Linux haters world. Okay, and environments, the next thing. You can think about the environments as use cases for the distribution. When you think about them, there are groups of groups, but deep down there are the real use case of your distribution. For example, there is development workstation, GNOME 3 desktop, KDE Plasma, whatever. But the whole working distribution, there could be, for example, high availability web server, high availability database, so on. And after we make this whole mess and this whole thing, repository, package, and so on, we make the system images. The first one, I'll call the whole installation ISO, is the first image that allows to install our system. Then we have some virtualization images, cloud images, containers, so on. And right now, I want to stop for a little bit, because there is automatic installation. And if we want to test the Linux distribution, we need that. Especially if we want to automate the whole process. But we really need that. I will give you a short example. Each installation takes, let's say, about 20 minutes. You know, the fat one. Like the really fat, nearly all packages and so on. And you should run this installation on, let's say, at least 10 platforms. So if you don't have an installation, the automatic installation feature, it's slow, it's boring. You don't have a way to automate it. You need to manually enter things to your computer. You cannot make the special file, kickstart, preseed, bash shell script, whatever, to make the installation automatic. And when you think about it in the tester way, the automatic installation gives us the data-driven testing. Yes, what is the data? The data is kickstart, this file special, but defined what should be installed and in which way. And the very last thing what we should consider when we are making a distribution is how we will release the updates and new software. And there are three popular ways to do it. First one is time-based. So we release software, for example, to the testing repository, and we wait. If someone may ask, hey, hi you, where is the problem? It's not working. Is this good? Definitely not. Especially when we think about how right now we are making the software. Yes? We all want this loop back, this feedback faster. Why we make continuous integration, continuous delivery? To get the feedback faster. And time-based? Do you really believe that putting something into repository for 2 months, for example, will make it stable? Next one is point-based, is Fedora way. They have in the infrastructure they have the thing called karma. So you literally can downvote or upvote the package. You know, like memes on some popular sites. You like it, it's working. Upvote. You don't like it, downvote. And the automated way. This is the ideal one and the one we should think about. So you have this test sets connected to, for example, these packages. You run it, and when it passes, you decide, OK, it's released. OK. The last thing is that the security packages can disturb the whole process. As said before, when there is day 0 exploit, the serious one, you just put it. You know, there is no time for time-based, for example. You won't wait 2 weeks, even the week, in order to fix something like it. OK. Oof. Yeah, here we are. Finally, we'll talk about the testing itself. And we'll get the current state of the testing. You know, there's some pseudocode. And this is current state of the testing. Linux was always community tested, always. And I will be honest with you, when I looked at how distributions are tested, I was shocked. I really am. Because go to the distro watch. There's the website that watch the distribution. Go to the distro watch, take the first 20, let's say, distribution, and there should be the Bugzilla, Manti, or something like the URL where you can submit the bugs. And look what a lot of them don't have it. Really. This is awkward. And Linux was always community tested. For example, Windows Store was during holidays and Christmas Eve. Wrote the email, "Hi guys, there is the new release of kernel, so if you want, if you have some time, just test it." And it's still really popular way to test things. When you look, for example, at the mailing list of distributions, for example, I don't know, Apple is extra packages for enterprise Linux, the scientific Linux development list, the CentOS development list, the Fedora development list. There's still a popular way to do it. And I can prove it because there are test days. There are days where the community says, "Whoa, today we will test the kernel." And you look at it, and there's 20 people who test the kernel. Then, whoa, we will test the new Java. When we will test the new, and you make this events. So we're manually tested. There are testing repositories, I already said. There are beta testing of whole release. I'm not against it. I'm not against it. But this proves that it's still community tested. And these two things are the real proof. The first one, there are no any meaningful test set on version control system. Go to your favorite distribution, look at their version control system, their Git, and find some useful automatic tests. Few of them has it. Most, forget about it. And there is no continuous integration because it's a very publicly available solution. There is the one distribution, or two, sorry. Both of them are supported by Red Hat. CentOS and Fedora. Maybe let's say that SUSE also has something like it, but not in the manner that I would say that it should be done. Okay. And the current state can be discouraging because, as I said before, testing the whole distribution means testing of thousands of packages. Like 1,000. You know, look for example at Void Linux. Void Linux is some little distribution that nearly died a year ago because the main developer disappeared. Nobody knows what had happened to him. And maybe he is dead, maybe not, I don't know. Nobody knows. You know, the one-man distribution. One man. 8,000 packages. And 1,000 packages to test. One-man distribution. And it can be discouraging. But when I thought about it, well, everything what is worth doing is hard. And even if one day there was plenty of days like this, I feel like this is a bad day. I always remember, come on, this is a bad day, not a bad life. And if you want to be proud of something, it probably must be hard. And it is hard. So, we will reset a little bit. We'll make retests of how things should be done, and we'll slowly implement it into the distribution. We start once more from bottom, the package. And I strongly believe that the testing must be built in the package building. Must be. People won't run tests when they don't have to. And there is multiple problems with why people don't make packages with tests with tests that will be run during the build. You know why? Because they believe. They believe that this is the stable release. This is the stable release. Oh, come on, guys. Easy, easy. At the same time, there is the great guy called the Linux Torvalds himself. And he said this. Making binaries for Linux desktop application is pain. You don't make binaries for Linux, you make binaries for Fedora 19, Fedora 20, maybe Vero 5 from 10 years ago. You make binaries for Debian Stable. Well, no, you don't make binaries for Debian Stable, because Debian Stable has libraries that are so old that anything built in the last century doesn't work. So, of course, some people might say, Alex, wait. He said about desktop applications. But if you dig a little bit, there's not the problem with desktop application only. There's the problem of whole Linux ecosystem, the whole ecosystem. So, it's mentally and logically impossible to say that each distribution is different and because of that, there is the problem, and say, testing is useless because we are using the stable releases. And it's represented by this. This very evil Kermit meme that I'm really enjoying. The one good side of packages say, run tests! And the bad one say, there's a stable release. Okay, the next problem. A lot of them have a real weak test set. And the newer one, look at the GitHub, for example. Nearly every bigger project on the GitHub has a coverage. Has the continuous integration, maybe the continuous delivery, Travis, so on. It's really changing. People want to join the project who has the good documentation, who has everything set up. But, oh, I wrote the code. Oh, test passes. Oh, nice. You know, the chatbots. On the other hand, let's be honest, when we have the chatbot, the bot that will, there's the commit, and when we wrote the bot test, it's like, Ray, do you need that? It cannot be automatic if you every time do that. Okay, but it's another topic. The next one is the reverse of previous one. So sometimes there are too many ways to test the software, and the Linux kernel is the best example, because, well, we have the Linux text project, we have the kernel self-test, the static code analyzer, the fusers, whatever they are, fusing testing, it's called, it's fusers, yes. And we have subsystem and kernel self-test. So many ways. Which one? Some of these tests are for the developers, some maybe for the people who make this distribution, who distribute the kernel. And you need a little bit of the time, some expertise and experimentation to find the right way to test the software. And the other thing that might be a little bit problematic is that how to test patches introduced by the distribution. For example, nearly always you need a little patch. Let's say that I want to distribute the Apache server, okay? So the first page of Apache server is like, welcome to Apache server, something. And all of the distribution has the patch who makes, welcome to Apache server on my own distribution. Yes? And how should we test the patches? Some of these patches are not trivial as this one. The one that are not trivial are backported features. So you have the points release, the older software, and you take something from the newer software. But sometimes it's impossible, even if they are tests, impossible to make them. Why? Because, for example, the test library have changed. The newer version is required. And well, your distribution won't have this version ever, like ever, because there's the enterprise Linux. And how we should manage with it? And the last of the big problem is the package builder support for the test. I will talk about it a little bit later. Okay, so the first test, like real test, like entry level, what we will make automated, is test on metadata. And they're quite easy, you know, like no-brainers, literally. So we choose we check the chosen attributes. The ones that are really important, keys, GPG keys. If keys, for example, are not present in the URL, the software won't install. If there is the wrong key, for example, development key instead of a production one, the software won't install. The things also we can check with checksums. Generally speaking, the package builder should support it, but not all package builders support it. License and description. Each package should have the license and description, so it shouldn't be empty. This is really easy test. If a packager, vendor, provider, we can check if, for example, if the build host is real with regular expression, or if the source's URL is valid. The next level of test, and these tests are, in my opinion, the most important, is the test during a package build. And I said before, package builders and programs, not the hosts, because this term is used interchangeably. And so programs, not physical virtual machines, have minimal support for testing, and well, like minimal. Like most of them don't have a special clause tests. So what should be done is that you can make the snapshot. You build the software. You make the snapshot. You test it. If test passes, you go with your build process. And this is quite important because sometimes the testers have, the test artifacts are different from the build artifacts. For example, you don't need all the libraries in order to, you need all the libraries to build and some additional libraries to test. Or test artifacts make, for example, additional directories on some additional files. And packagers don't like it. Why? Because we are using the regular expression to include files into the package. So it's quite easy to miss, for example, that there is the automatically generated report after test, and you include it in the package. And the last thing is that the build is different than runtime environment. And this is the first thing that I decide that we should get rid of. Like, no. Why? Because some tests require the same version. People make the build host, and this build host have mocks in them. So they can mock the different environment. It's generally speaking change root with install software on the other partition, on the other place, then use these libraries. But sometimes you cannot run tests. I will give you a real example of this edge case. You have a web server, and you have the older enterprise Linux version 6. And this web server has reuse port. So this is the special feature of the kernel when one program, many programs can use the one port from the kernel. Generally speaking, it wasn't possible, like, I don't know, 5 years ago. And if you want to test it, you cannot test it in mocked build system, because you need the real kernel, like real one, not the mocked libraries that of course will build software, but sometimes we won't test it. Okay. Oof. The next one is the fact that whenever, the next thing is that whenever we want to invoke tests, the package manager, the person who makes packages need to dig into the project. As I said, there are thousands of projects. Some of them are C, some of them are Python, some of them are like Ruby, and so on and so on. So each time you need to read README, and if there is no how to test, you are bad, you are angry. Please include that in your project, really. Oh, there's duplicated information. Okay, and as some of you might already notice, this slide is duplicated. Why? because this is really important, and I will firmly stand that this is the most important thing that I can say to you about the automating industries. Okay. The next test will be on repository level. And we'll start with the easiest one. So the first one is the testing of our content delivery network. So if all local packages are really available on the content delivery network. There's like 5 lines in Bash or whatever, Python. And test on metadata if metadata match patterns. The next one that, the second, by the way, the second test that I personally made is using the random operations on repository. So generally speaking, you make the virtual or physical machine, install it or just boot it. Then you make some operation like install packages, update these packages, downgrade these packages, install the whole group of whole environment, start the selected services, start the newly installed services, and so on and so on. The really important thing is after all of this, or after some of these steps, you have to reboot, restart your computer, restart this machine, virtual physical machine. Why? Because when Linux kernel start, a lot of things are loaded. And for example, some services can work, but won't work after the restart. And especially with the Linux kernel, if you make the bad Linux kernel, your machine won't boot the neck after the reboot. So it's like must-have. Okay? I call the test system consistency and services. Okay. The next thing that I want to talk about is that the really smart man, and probably most of you know the smart man because he on this conference taught me, but the other smart man thought that the tester find the graph and then cover it. And when we think about testing the Linux distribution, the most obvious graph is the repository itself. The verticals are packages and the edges are dependency relation. And the test that we definitely should make are check for dependencies, search isolated verticals. If any vertical is isolated, so any package is isolated, it's definitely the wrong package. Something is wrong. Where is the bug introduced? And extremely useful for update testing, the neighborhood. So we have the package, and if other package need this package, we also test them when there is the update. We test if they build, if their test passes, and so on and so on. So we have this trust that not only the most important test is the repo closure. It's the easiest one. It's called by NPL community. We check if all dependency passes. And we can make the impact score. So for example, when it's the kernel has the huge impact of the system, but if there is some not important package, it has like 1 or 2. Okay, the use cases. This is connected to the acceptance test. How to obtain the use cases? Because there is quite not obvious question. We have the distribution, but how people use it? The easiest answer, use the automated platform. And each automated platform has a special portal when they gather the most important roles and use cases of the distro. And there is Puppet, Forge, Salt Stack Formulas, Ansible, Galaxy. And we can take these cases, then test them. Some of the popular sample use cases, for example, Linux, Apache, MySQL, PGP, NFS, Samba, Web Server, Availability, databases, so on, so on, so on. And this is something, right now is something very important, the core test suite. So generally speaking, when you make this test, you should gather this all tests together and choose the most important one in order to get the core test suite, as I called it. This test suite will be run against nearly every image that we will use. The next level, when we have our the next and final level is test on system images, and the most important is the holy one first ISO, and this test can be, all of this test can be run by one thing, and I will skip to it because we don't have time. It's OpenQA. I want you to go to this website, open.qa, and look at it. It's the project provided by SUSE. It can check the whole life cycle of Linux distribution. Like how it makes movies. It's like Selenium, to be honest. It's like Selenium, but for Linux distros, and you need to know the pair, what it means that you want to cut yourself and your family, but okay, you can use it, and it's nice. The overall tools that are really important is Linux standard base. It's not as popular as it used to be. The whole idea is to make Linux standardized. And there is a huge test set that you can run and test and check. There's the thing that Linux software base is provided in Red Hat package manager format. So it's like, who benefited? And over Linux distros, like, I am joke to you. Okay, the next, this is how it looks like. File system hierarchy standard. This is the most sensible standard in Linux. It's say how the directories should look like and what binary should be in these directories. And there is Linux test project. This is the most important project when it comes to the test the Linux kernel. If you make the distribution, you want to use your kernel, you really need that. It's like the basics. And I want to summarize. Sorry that I skipped quite a bit, but I want to summarize. Any packager, any distro maker cannot impact the software that he has chosen. You know, there's too many packages, too many projects that these packages provide. And the thing that we can definitely do is run provided test, and from this level up, make automated test on our own. Keep our hands clean and nice. And that's all. So, are there any questions? Because we have like 1 minute. So, please.
In Polish maybe.
Okay, that's not a problem.
Dobra, mam takie pytanie, bo rozumiem, że testujecie jakieś swoje distro pod względem...
W dużej mierze. Mamy, powiedzmy, że kilka takich projektów.
Jak wygląda wasz lab? To znaczy, czy to są fizyczne maszyny, wirtualizacja?
Właśnie o tym mówiłem, nie wiem, czy to dobrze podkreśliłem, że trzeba testować absolutnie wszystkie, tak? Bo na początku macie maszyny fizyczne i od nich się zaczyna. I one są trudniejsze do testowania, dlatego że, no mówiąc szczerze, mając laboratorium ze 30 różnych hostów, mało. Tak mówię, powiem szczerze, no mało wciąż dla nas. I to, co najfajniej się testuje, to są wirtualizacje w chmurze, tak? No bo chmury to tak naprawdę wirtualizatory. I no moim ulubionym to jest jednak Azure. Azure ma, przepraszam, że tak powiem, ale bardzo dobrą dokumentację, jeżeli o to chodzi. I no w ten sposób się to po prostu testuje. No i na wszystkim, tak? Od dockerowego imidża, który jest po prostu wyciętym CH-rootem, gdzie masz dosłownie tylko kilka bibliotek i ważysz 30 megabajtów, po no, pełną grubą instalację na systemie fizycznym. Od najlżejszych po najcięższych, dlatego ten core test suite, jak go nie nazywamy, jest taki istotny, bo on wszędzie powinien móc zostać uruchomiony i wszędzie powinien zostać uruchomiony. Pytanie, jakie testy?
Przepraszam. Jak długo trwa testowanie takiej dystrybucji?
Okej, LSB 8 godzin, tak na bidę. Tak, czyli Linux Standard Base trwa 8 godzin. Żeby przetestować wszystkie testy, które mamy, podejrzewam, że 24 godziny, ale mówimy o bardzo szybkich komputerach, tak? Mówimy o komputerach, które mają za sobą macierz z dyskami na SSD-kach i mają dość dużo pamięci RAM. No i to dość mocny procesor. Po prostu mówimy tutaj wciąż o bardzo szybkich kompach. I no z 24 godziny, żeby wszystkie testy przeprowadzić tak na bidę.
I przeglądacie rezultaty? Czy te
tak, rezultat. Z czego to wygląda najłatwiejszy sposób jest...
To wiesz, przez 24 godziny bardzo dużo testów może tak naprawdę...
Dobra, okej. Rezultaty są na samym początku sprawdzane, tak? To jest jakby pierwszy step, po czym robi się wszystko, żeby w momencie, kiedy coś jest nie tak, żeby exit status był po prostu inny. I w momencie u nas to działa tak, że jeżeli jakikolwiek test failuje gdziekolwiek, to od razu dostajesz maila o tym, tak? I co jest istotne, część testów jest wykonywana nie tylko wtedy, kiedy są update'y, ale są też testy, które są wykonywane co 24 godziny. I teraz jeszcze motyw... Sorry, mogę? Okej, dobra. Dobrze, to ja dziękuję Państwu, thank you very much and... Okay.
Thank you very much, Aleksander.